Welcome to Easy BTech channel, students. Please like, share, subscribe Easy BTech channel. And today my topic is maximum and minimum of functions of two variables. So let f of x comma y be a function of two variables. Be a function of two variables of x and y, two variables of x and y, and then f of x comma y is said to have maximum at x is equal to a and y is equal to b if f of x comma y greater than f of a plus h comma b plus k. Okay, and f of x comma y is said to have minimum at x is equal to a and y is equal to b, at x is equal to a and y is equal to b if f of x comma y less than f of a plus h comma b plus k. So here the values of h and k, here h and k are very small arbitrary value. Okay, students. So next coming to extreme value definition. Extreme value. Okay, the definition of extreme value is f of a comma b is said to be extreme value of the function f if it is maximum or minimum value. So for function f of x comma y is said to be maximum when f of x comma y greater than f of a plus h comma b plus k, and f of x comma y is minimum. So if f of x comma y is less than f of a plus h comma b plus k, and where h and k are said to be very small arbitrary values. So coming to the extreme value definition is f of a comma b is said to be extreme value of f if it is maximum or minimum value. Okay, so now the working procedure of maximum and minimum. Okay, the method to find working procedure or method to find maximum or minimum value of x or minimum value of f. Yeah, so the first procedure, that means in method, the first step is find dou f by dou x and dou f by dou y. Okay, students, f is nothing but f is the given question here. So the first step is finding partial differentiating of f with respect to x and y, and equating to 0, equating each to 0. equating each to 0. Okay, so equating each to 0 means dou f by dou x is equal to 0 and dou f by dou y is equal to 0. Equating to 0 at first is doing partial differentiating of f with respect to x and y and equating to 0, and solve these equations for x and y for solve these equations for x and y values. So let the values are a comma b. Okay, so now the second step to find maximum or minimum of a function. So the second one is find r is equal to dou square f by dou x square, s is equal to dou square f by dou x dou y, and t is equal to dou square f by dou y square. Okay, finding these three values. And the third one, if rt minus s square greater than 0 and r is less than 0, then the function f is the function, then the function f has rt minus s square greater than 0 and r is less than 0, then the function has maximum value. The function has maximum value at a comma b. Okay, and coming to the fourth point. So if rt minus s square greater than 0 and r greater than 0. So observe third condition and fourth condition. In third condition, rt minus s square greater than 0 and r less than 0, and in our fourth condition, rt minus s square greater than 0 and r greater than 0 here. So then the function so that function is f, then the function has minimum value. The function has minimum value at the point a comma b. Okay, and one more point, the fifth point is also there here, solving maximum and minimum. Yeah, coming to the fifth one. So if rt minus s square less than 0, okay, rt minus s square less than 0, then the function f not an extreme value. So not an extreme value means here neither a maximum and nor a minimum. So these are the working procedure or method to find maximum and minimum. So what is the first step, students? What is the first step here? The first step is finding partial differentiating of f with respect to x and y and equating to 0. And second one is and of course the solving these two equations and getting the values of a and b, that means x comma y in terms of a and b. And the second point is finding the value of r here. R is dou square f by dou x square, and s is dou square f by dou x dou y, and t dou square f by dou y square. And third step, if rt minus s square greater than 0 and r less than 0, then the function has maximum value. See here students, when the maximum is there for the function means here, if rt minus x square greater than 0 and r less than 0, observe the symbol here, okay. rt minus s square greater than 0 and r less than 0 is there for any function, then you can say that the function has maximum value. And similarly, rt minus s square greater than 0 and r greater than 0, then the function has minimum value. So minimum, so when the function will be the minimum here students, if rt minus s square greater than 0 and r greater than 0, then the function has minimum value. Suppose if rt minus s square is less than 0, then you can say that for the function neither maximum and nor a minimum value, that means not an extreme value, okay, not an extreme value. So one thing you have to remember here students, the functions, when the function will be maximum and when the function will be minimum here. See here in third and fourth condition, in third condition also rt minus s square is greater than 0, and in fourth condition also rt minus s square greater than 0. So for both that means for maximum and for minimum, rt minus s square value is greater than 0, okay. And in maximum condition r is less than 0, okay. Maximum condition r is less than 0 and in minimum condition r is greater than 0. So that means here, so when we are writing the maximum and minimum conditions, so for this both conditions the similar value is rt minus s square greater than 0 for this both conditions, maximum and minimum, okay. And only the r value will be changes here. So when r greater than 0, the function is minimum value, and when r less than 0, the function is maximum value. For this both functions, maximum and minimum, the common term is rt minus s square greater than 0. Again I am repeating the students, for maximum r less than 0, rt minus s square greater than 0. For minimum r greater than 0 and rt minus s square greater than 0. If both greater than values are there, then function has minimum value, and one value is less than 0 and one value is greater than 0, then you can say that the function has maximum value. So you have to remember these key points when we are doing the problem here, okay. So coming to the problem related to this topic, maximum and minimum. And then now the question here I am writing. So find maximum and minimum of maximum and minimum of u is equal to sin x and sin y and sin of x plus y, where the conditions 0 less than or equal to x less than or equal to pi, 0 less than or equal to y less than or equal to pi, okay. So now the solution. So it was given that the value of u is equal to sin x and sin y and sin of x plus y. So okay, maximum and minimum. So the first step is finding dou f by dou x and dou f by dou y and equating 0 to both values. That is the first step, okay students. Yeah, first one I am doing dou u by dou x here. So when you are doing partial differentiating of u with respect to x here, then in middle sin y term is it, then it is constant, then sin y as a common, then dou by dou x of sin x into sin x plus y. Okay, because both functions having x variable, you have to use u into v procedure. then sin y. So u into v procedure, that is sin x, dou by dou x of sin x plus y, and plus sin x plus y dou by dou x of sin x. Okay students, so now doing the differentiation partially. So sin x, okay, dou by dou x of sin of x plus y. Sin partial differentiation is cos, that is cos x plus y, and plus sin x plus y into sin x differentiation is cos x. So here we are using a trigonometric formula to evaluate this one. So that formula is sin a cos b plus cos a sin b is equal to 2 sin a plus b, students. So sin a cos b plus cos a sin b is nothing but sin a plus b. Okay, sin a plus b is equal to sin a cos b plus cos a sin b. So here I am applying that formula. See here, sin a and cos b and cos a and sin b. Okay, according to this formula, the value of a is equal to x and the value of b is x plus y. So what is the related formula here? The related formula is sin a plus b. Then the value is sin a plus b. That means sin x plus y. Then sin of 2x plus y is the value of this total term. Okay, so now I am writing that value here. So sin y into sin of 2x plus y. So which value, students, this one? This is the value of dou u by dou x. So according to the method of maxima and minimum, so first doing partial differentiating of the given function with respect to x and y, equating each to 0. Okay, so now this is the value of dou u by dou x. According to the procedure, dou u by dou x is equal to 0, equating to 0. So dou u by dou x value is sin y and sin 2x plus y is equal to 0. So please, it is equation 1. So similarly, doing partial differentiating of u with respect to y here. Okay, partial differentiating of u with respect to y. So now I am writing u here. So u is equal to sin x and sin y, sin of x plus y. So now I am doing partial differentiating with respect to y. So when we are doing partial differentiating of y, sin x as a common here, sin x common, dou by dou y of sin y and sin x plus y. Okay, so here also applying u into v, because this sign both product terms contains y variable here. So u into v formula, sin y dou by dou y of sin x plus y and plus sin x plus y dou by dou y of sin y. So now doing the partial differentiating, sin x and sin y. For sin differentiation is cos x plus y, and plus sin x plus y, sin y differentiation is cos y. So again verifying the trigonometric formula here, which one is suitable. Okay, so now I am writing the formula. Yeah, that formula is sin a cos b and plus cos a sin b. The same formula, students, that is sin a plus b. See here, it is a and this one is b, and cos a, this is a sin b. So according to this term, the value of A is y and the value of B is x plus y. So the applying the formula answer, that is sin A plus B. Substitute the values. Sin A means here y and B means x plus y. So sin of x plus 2y. Okay, now I am substituting this value here. So that value sin x into sin of x plus 2y. So what is this value, students, here? So not x plus 2y here. Not x plus 2y. Yeah, of course, x plus 2y. Okay, x plus 2y only. X plus 2y. So that the value of this one is dou u by dou y. Okay, according to the procedure, we have to equate this dou u by dou y also 0. That means dou u by dou y is equal to 0. Then sin x into sin x plus 2y and is equal to 0. So it is second equation. So the first equation is sin y into sin 2x plus y, and the second equation sin x into sin of x plus 2y. So now according to the method, solving these two equations to get the values of x and y. Okay, so now solving these two equations here. Solving equations 1 and 2. Okay, so what is the equation 1 here? Equation 1 is sin y into sin 2x plus y is equal to 0, and equation 2 is sin x plus 2y is equal to 0. So product terms are equal to 0 here, then equating to 0 to the each product term, that is sin y is equal to 0. So sin of 2x plus y is equal to 0 and sin x is equal to 0 and sin of x plus 2y is equal to 0. Okay, so now according to this equation, we will get the value of y is equal to 0, and by using this equation, we will get the value of x is equal to 0 here. Okay, and for this function, 2x plus y is equal to pi and x plus 2y is equal to pi. Because the sign term is 0, will be equal to 0 for first value is 0 and plus or minus n pi. So n pi means for pi value, substituting for pi for sin trigonometric term 0, for 2 pi 0, and for 3 pi 0, and for 4 pi also 0. So first we choose we are taking the value of for 0 term as a pi here, this pi 2x plus y is equal to pi and x plus 2y is equal to pi. So coming to these two values, y is equal to 0 and x is equal to 0, this one becomes as one extreme point here. So now solving these two equations, solving 2x plus y is equal to pi and x plus 2y is equal to pi. So to make the variables coefficients as equal, here 2x is there, so do the multiplication of 2 to the next equation, or you may equate to the variable y coefficients as equal, that is your choice. Then the first equation is as it is, 2x plus y is equal to pi, and multiplying with 2, 2x plus 4 pi is equal to 2 pi. So doing the subtraction, minus, these two values will be cancelled. Y minus 4y is minus 3y, and similarly pi minus 2 pi is minus pi. So that implies here y is equal to pi by 3. So one value. Okay, y is equal to pi by 3. So substituting y value in any one of the equation, that is 2x plus y is equal to pi or x plus 2y is equal to pi. Substitute this value. 2x plus pi by 3 is equal to pi. 2x is equal to pi minus pi by 3, and LCM is 3. 3 pi minus pi, that is 2 pi by 3. Then 2x is equal to 2 pi by 3. 2 will be cancelled. Then the value of x is pi by 3. So the value of x is pi by 3. At the same time, the value of y is also pi by 3 here. Okay. So now coming to the problem. So the values of x and y. So the extreme values or maximum and minimum values. Extreme values. X comma y is equal to 0 comma 0 and pi by 3 comma pi by 3. Okay. This is the first step. Okay students, the partial differentiating of f with respect to x and y, but in this question u was given here. Then partial differentiating of u with respect to x and y and equating to 0 and solving the equations to get the values of x and y. So that points are known as the extreme points. Either it may be the maximum value or minimum value on that point. Okay. So the second solution, I mean second step here. The second step, finding RST. So R is nothing but dou square f by dou x square. Okay. So how to find out this differentiation? Then dou square f by dou x square may also be written as dou by dou x of dou f by dou x. So that means dou by dou x of. So we are having dou f by dou x. That means equation 1. That is sin y into sin of 2x plus y. Okay, with respect to x here we are doing partial differentiating students. Then sin y as a common. Okay, sin y as a common here. So sin y common. Then dou by dou x of sin of 2x plus y. Yeah. And sin y, now doing the differentiation. So sin of 2x plus y with respect to x here we are doing, that means cos of 2x plus y and again into 2. Okay. Then 2 sin y cos of 2 sin y cos of 2x plus y. 2x plus y. Yeah. So now finding the value of r at the point of x comma y. So here x comma y is having the 2 points. Of course 0 comma 0 point, if you are substituting in the place of x as a 0 and y as a 0 here, sine term is there here, then total function becomes as a 0. So that's why we are choosing the point, second point, that is r is equal to pi by 3 comma pi by 3. So 2 sine, this value is x and this value is y students. 2 sine pi by 3 cos 2 pi by 3 and plus pi by 3. Okay. 2 sine pi by 3 cos 3 pi by 3. 3 will be cancelled. Then 2 sine pi by 3 and cos pi. So pi by 3 means how much students? Then pi by 3 means 180 by 3, that means 60. So I have to write down the sin 60 value there. Okay. So the substitution, the value here. Okay, substituting the value, that is 2 sin 60 and again pi means cos 180. So now writing the value, yeah, corresponding value. So and here cos of x plus y. Yeah, okay, and this value is 2 root 3 by 2 minus 1. Okay, sin 60 is root 3 by 2 and cos 180 is minus 1, that is minus 3, and here cos of 2x plus y. Okay, and now the value of r is equal to minus root 3. Yeah, next finding the value of s here. So s is dou square u by dou x dou y, that means dou by dou x of dou u by dou y. So substitute the value dou by dou u by dou y here, then dou by dou x of dou u by dou y value is sin x into sin of x plus 2y. Applying u into v procedure, because the product terms both contains x variable, sin x into dou by dou x of sin of x plus 2y and plus sin of x plus 2y into dou by dou x of sin x. Yeah, now doing the differentiation. Sin x, then sin differentiation is cos of x plus 2y and plus sin of x plus 2y, sin differentiation is cos. Then using the trigonometric formula, sin a cos b plus cos a sin b, sin a plus b. Okay, this value is a and this value is b. Then finally the answer is sin of 2x plus 2y. So finding s at the point pi by 3 comma pi by 3. Now substituting sin 2 pi by 3 and plus 2 pi by 3, that is sin 4 pi by 3. Then 4 pi by 3 value is minus root 3 by 2. Yeah, next finding the value of t here. Then the value of the formula for t is dou square u by dou y square, dou by dou y of dou u by dou y. Yeah, substituting the dou u by dou y value here, dou by dou y of dou u by dou y is sin x into sin of x plus 2y. So here sin x as a common, because we are doing a differentiation with respect to y, and for sin partial differentiating is cos, and again for the function this 2y, the differentiation as a 2. Then finally the answer is 2 sin x cos of x plus 2y. So now finding the value of t at the point pi by 3 comma pi by 3. Then 2 sin pi by 3 cos of pi by 3 and again 2 pi by 3. Then 2 into root 3 by 2 and it is cos pi. Then 2 will be cancelled. Then root 3 into minus 1, that is minus root 3. Yeah, now finding the value of rt minus s square. So here the value of r is minus root 3 and the value of t is also minus root 3 and minus s square. So minus s square, so minus root 3 by 2 whole square. Then minus root 3 into minus root 3 is 3 and minus root 3 whole square is 3 and 2 square is 4. That means 12 minus 3, that is 9 by 4. Then it is a greater than value. So here r is less than 0 and rt minus s square greater than 0. So hence the function has maximum value. Hence the function has maximum value at the point. At the point is pi by 3 comma pi by 3. Okay, so now finding a maximum value. Okay, what is the maximum value of the given function at this point? Then maximum value. maximum value of u. So the question is sin x, sin y, and sin of x plus y. So substitute the points here, that is sin pi by 3 and sin pi by 3 and sin of pi by 3 plus pi by 3. Then the final answer is nothing but here 3 root 3 by 8. This is the maximum value of the function at the point pi by 3 comma pi by 3. Thank you, students.